We will continue now from the last lecture and talk about a particular measure of location called a percentile. The last lecture we looked at interval data in frequency distributions, and the percentile is a measure just like the median, and actually we'll see in a little bit that the median is a particular kind of percentile, and this is useful now for the real world in terms of understanding what percentiles are, because there are many different measures like percentiles, Steinians for instance in education, quartiles in more academic literature. That is important for everybody to know, but also later we'll in our probability distributions it's handy to understand what a percentile is. Alright, so let's do it by example. Let's say that we're looking for the 25th percentile. We'll denote that by P25. Alright, so that's the 25th percentile. Alright, the definition of this is that 25% of the items in the sample population lie less than or equal to the 25th percentile, and therefore, of course, the rest, 75% of the items, lie above the 25th percentile. So if somebody gets a score on a standardized exam like the ACT or the SAT and they get in the 25th percentile, it's not exactly a very good grade. But if you on the same exam got on the 99th percentile, that is a good grade. Okay, because it means that 99% of the items are less than or equal to the 99th percentile, alright, which means that only 1% of the items are better than the 99th percentile. So if you've got a 99th percentile of a particular exam, that means that only 1% of the population got better than you did. Alright, so that's pretty good. In general, we will talk about the jth percentile, P sub j. Alright, so given those definitions for percentiles, what is the median? What percentile is the median? Well, the definition of median is that 50% of the items lie below the median and 50% of the items lie above the median. So the median is the 50th percentile. Okay. We will only concern ourselves with estimating the percentile for interval data. The formula for that is very, very similar to that for the median. So P sub j is L plus I. Instead of the n divided by 2, now we have j n on 100 minus the capital F divided by little f. Alright, so now we're interested not in the median class but the percentile class or interval, and that contains the jn on 100th item. The calculation jn on 100 does not have to be a whole number. Okay, so there could be the 9.3 item. Alright, so L now, instead of being the lower limit of the median class, is the lower limit of the percentile class, and I'll abbreviate percentile this way. I is the width of the percentile class. J we know is the percentile that we're looking for. N sample size. F, capital F, the cumulative frequency up to the median class, or say the percentile class. In other words, is the number of items below the percentile class. Little f is the frequency of the percentile class, the number of items in the percentile class. Alright, so basically it's the same process of calculation that we did for the median. So let's use the same example, the same data sets that we used for the last example of the median. And I will pause the screen, or pause the recording while I write that up. Alright, so this is the example that we had before. These were, for instance, current interest rates paid on mortgages in a sample of 25 homeowners. Alright, to do these calculations, first we need to start with the cumulative frequency. Tell us the number of items below the upper limit, and this is the same as we had for the median. So it'll be 3 for the first interval, then it'll be 3 plus 4. Alright, 3 plus 4 is 7. 7 plus 8, 15. 15 plus 6, 21. 21 and 1 is 22. 22 and 3 is 25. Make sure that these are equal. Alright, the last cumulative frequency and the total frequency, of course, have to be the same. Alright, so let's say that we're looking for the 20th percentile, p sub 20. Alright, so where is the 20th percentile? So we'll look at the calculation Jn on 100. J is 20 for the 20th percentile. N, number of items in the sample, 25, divided by 100. Alright, and that calculates out to 5. Alright, so we're looking for the 5th item. So we go through this list of cumulative frequencies, and whenever we pass 5, that means we've got that item, in this case the 5th item, in that interval. Alright, so in the second interval there, 5.5 to 7, we have a cumulative frequency of 7 there. The class below it, we had a cumulative frequency of 3. That means we have items 4, because there are 3 below there, through 7 in this particular interval, and of course that contains the 5th item being P20. Alright, so this then is the percentile class. This meaning 5.5 through 7. Okay. Alright, so that being true, then we pull out the information that we need. We need the lower limit. Well, that's 5.5, since it's 5.5 through 7. I, the interval width, 5.5 through 7, is a width of 1.5. J, Well, that's the 20th percentile. N, sample size, 25. Alright, capital F, that's the cumulative frequency up to the percentile class, or it's the number of items below the percentile class. It's the 3 here. And then little f, the cumulative frequency of the percentile class, and that's 4. Alright, so given that information, we can then put it into our formula. Alright, and the formula for the percentile Pj is equal to L plus I Jn on 100 minus capital F divided by little f, and so P20 is equal to L 5.5 plus I 1.5, Jn on 100, well, we've already calculated that. That was the 5th item, minus capital F, alright, 3 items below the percentile class, divided by little f, the number of items in the percentile class, that's 4, and when you work that out, you get 6.25. Make sure that you check and see it's actually in your percentile class, that is between the limits that you chose for your percentile class, and 6.25 is indeed between 5.5 and 7.